bombastic side eye, criminal offensive side eye.
Tapi bohong.
Background of study. The study uses statistic analysis to identify factors affecting urban health. Understanding these factors help address health energy use, reduce comfort and health-related health risks. Objective: to analyze the descriptive analysis of temperature, including the mean, median, and variance in select urban areas. To evaluate the correlation between urban density factor and the increase in surface temperature. To develop a regression model to estimate future temperature trend based on environmental variables. Data collection. Quantitative secondary dataset 20 observation. Study focuses on factors influencing the urban heat pollution index (UHI) effect in metropolitan areas. Variable, dependent variable, urban heat pollution index, independent variable, number of vehicles on the road, industrial energy consumption, and ambient temperature. Statistical method, multiply linear regression. To determine the relationship between urban heat pollution index and the selected environmental factor. To develop a predictive model for urban heat pollution trends. MLR model, Y equals B0 plus B1x1 plus B2x2 plus B3x3 plus E.
First, there's when you run the SPSS, there will be data view and variables view on the corner left of the window. Data view is for entering data values, and variable view is for defining variables. So we will start with variable views. First, define your variables. In variable views, enter on the name column and the UHPI, vehicles, energy, and temperature because it is in our variables. And then on the column of type, all type of the variables is numeric. And then when it comes to the decimal columns, for UHPI, the decimal number is 1. As for vehicles and energy, we can switch it to 0. And as for temperature, we will use 1 as well. As for the label, for each variables, just name it like you name it. Just name it as you type in your report. For us, it's urban heat pollution index, number of vehicles on the road, industrial energy consumption, and ambient temperature. And for the measure, all of the variables measurement is scale, and that's all. And then you will switch to data view, and you will enter all of the data that you have got in your data view. As for us, we have 20 observation or 20 data. Step 5, we have to generate histogram. First, go to graph, then legacy dialogs, and then select histogram. Then select UHPI, tick display normal curve, and then click OK. And you should repeat this step for vehicles, energy, and temperature. You will have to generate scatter plot. First, you will have to go to graph, then legacy dialogs, then you will click on scatter or dot, and then you will click simple scatter. First, for the first graph, we will have to choose UHPI, which is urban heat pollution index for our y-axis, and then vehicles for our x-axis. For scatter plots, we will have three scatter plot graph that refers to relationship of urban heat and vehicles. The second scatter plot will show you the relationship between urban heat and energy consumption, industrial energy consumption, and the third one is urban heat and ambient temperature. And then descriptive statistic analysis. First, you go to analyze, then go to descriptive statistic, and then click frequency. Then select all 4 variables into the variables box, and then click statistic on the right, and then select mean, median, mode, sum, standard deviation, minimum, maximum, all of the descriptive descriptive statistic analysis that we want, and then we will click OK, and all the descriptive statistic analysis that we want, there will be a table that shows all the things that we want to see.
In this video, I will show you how to set up data application in SPSS. Go to Analyze, Descriptive Statistic as well, move urban heat pollution index into the dependent lens. Click plots, select histogram and normality plot with test, then run the analysis. SPSS will generate histogram and normality plot to help us evaluate the data distribution. Now, let's run the regression. Go to Analyze, Regression, Linear, place in the dependent plot and independent variable. Under Statistic, check Estimate, Model, Fake, and Collinearity Diagnostic. In plots on the Y and X axis, and include the normal probability plot. In Save, select Coexistence to detect influential outlier. Finally, under Option and Show Missing Values, exclude list-wise. Click OK to run the regression. SPSS will produce labels, scatter plots, and PP plots. See coefficients, ANOVA, and diagnostic LFIF values. These outputs help you interpret how strongly vehicle, energy, and temperature predict the urban heat pollution.
In conclusion, the studies found that the number of vehicles on the road is the main factor contributing to the urban heat pollution. The regression model shows high accuracy, explain 97.1% of the variation in the urban heat pollution index. Therefore, reducing traffic congestion, promoting public transportation, and increase green space are important steps to reduce urban heat pollution and support sustainable urban development.